You sit down to patch a few boxes. First, SSH connection, passphrase. Second box, passphrase. Get pull from a private repo, passphrase. Copy logs with SCP, passphrase again. By the 10th prompt, people start doing the wrong thing, removing the passphrase from the private key, or reusing one weaker key everywhere. ssh-agent is the tool that prevents that bad trade-off. It lets you unlock a protected private key once, then use it repeatedly during your session without turning that key into an unprotected file. ssh-agent is a local helper process for OpenSSH. Its job is simple. Hold decrypted private key material in memory after you approve it, usually by typing the key's passphrase with ssh-add. Your SSH client then talks to the agent when it needs to prove possession of that key. The benefit is workflow, strong passphrase on disk, fewer prompts during the work session. The important boundary is this: the agent does not make the risk disappear. It moves the risk from a stolen key file to access to your logged-in session and the agent socket. That is better, but it is still a security decision. Mechanically, the agent listens on a Unix domain socket. Your shell learns the socket path through the SSH auth sock environment variable. When you run SSH, get over SSH, SCP, or SFTP, the client checks that variable, connects to the socket, and asks the agent to sign an authentication challenge. The private key itself is not sent to the server. The server verifies the signature using the public key already in authorized keys. On most Linux desktops, the agent is started for your login session by the desktop, PAM, systemd user services, or a keyring integration. Paths vary by platform and version, but the session idea is the same. Here are the core commands. First line starts a fresh OpenSSH agent and imports its environment into your current shell. Do not run that blindly on every login if your desktop already starts one. Check first. The second line prints the socket path your clients will use. The third line adds your ed25519 private key and prompts for its passphrase. The fourth line lists identities currently loaded, showing their public key fingerprints. The last line adds the same key with a 1-hour lifetime. After that time, the agent forgets the key, and you must unlock it again. Your key file should remain private. A normal admin pattern looks like this. You start a planned maintenance window on your laptop. You add your admin key with a 4-hour lifetime, matching the window plus a little cleanup time. Now SSH to Web 1, pull logs, run your normal configuration checks, and copy one application log to the log collector. During that period, SSH and SCP can use the agent without nagging you. When the window ends, remove loaded identities with ssh-add-D shown on the card. The protected key file is still on disk. The decrypted, usable copy is no longer sitting in the agent. The first mistake is adding keys with no lifetime and forgetting they are loaded for days. The second is leaving an unlocked workstation. If someone can operate your logged-in session, they can usually ask your agent to sign SSH challenges. Lock screen equals reducing agent exposure. It is not magic, and malware running as your user is still a serious problem, but a locked session blocks casual physical misuse. OpenSSH ssh-add can also lock and unlock the agent with -X and -X. Their desktop keyrings vary. Agent forwarding is a separate risk, useful in narrow cases, dangerous when enabled casually. This topic sits between key hygiene and day-to-day operations. Earlier in the Foundations tier, the message was, use key pairs, protect private keys, and understand what the server trusts. ssh-agent lets you keep that protection without typing the passphrase 50 times. Next, it connects directly to SSH config files, host aliases, Git over SSH, automation accounts, and bastion patterns. But do not confuse convenience with authorization. The server still decides access from authorized keys and account policy. The agent only helps your client prove you possess an already trusted private key. That separation matters when you audit systems. Try this on your own workstation or lab VM. Use your real test key path if it is not ID ED25519. First, clear currently loaded identities so the result is obvious. Add the key with a 5-minute lifetime, list loaded identities, and confirm the fingerprint appears. Then wait 310 seconds with sleep, and list again. The key should be gone, or at least that identity should no longer be available from the agent. If ssh-add says it cannot connect to an agent, start one with the earlier eval command, or log into a normal graphical session where your desktop starts it for you. 3 beats to keep. First, ssh-agent holds decrypted keys in memory so your clients can authenticate without repeated passphrase prompts. Second, ssh-add is the control surface. Add, list, time limit, lock, unlock, and remove identities. Third, this is not a security-free lunch. Your logged-in session and agent socket become valuable, so use lifetimes, lock your screen, and clean up after admin windows. Tomorrow we keep building the SSH foundation, one practical topic at a time. New SSH Mastery episode daily on this channel, plus the daily ranked CVE brief for defenders who need to know what to patch first.